Page 1. Cars, Past, Present and Future. Page 2. Contents. Page 3. Cars, Then and Now. The motor car is essential to the lives of millions of people around the world. Cars today are very different from cars in the past. Today, a car is a self-propelled vehicle, usually with 4 wheels, that is used as a means of transport. The development of the car began in the 19th century. The car was developed through a series of designs to create a method of travel that was more efficient than the horse and cart. Some of these early designs were successful, and others were unsuccessful. This early car, from 1905, is a motorized horseless carriage. Page 4. New cars are constantly changing. They have very complex technology and safety systems that make travel more comfortable and less dangerous. The early cars had very few of these design elements. Yet, at the time they were built, the vehicles were believed to be remarkable achievements. Modern cars are designed to be energy efficient, safe and stylish. Page 5. Types of engines. Steam engines. Steam engines were used to power the first motor vehicles by burning fuel that heated water in a boiler. When the water boiled, it created steam. The pressure of the steam moved pistons that turned a crankshaft. The crankshaft was connected to the wheels and made them turn, moving the vehicle forward. As the wheels turned, the valve slide moved to let fresh steam into the engine. Page 6. A steam engine. 1. Steam from the boiler enters the engine via a pipe. 2. The pressure from the steam pushes the piston. 3. When the piston moves, it pushes the crankshaft. 4. The movement of the crankshaft turns the wheels. 5. The valve slide moves as the wheel turns, which lets out steam and moves the piston again. Steam boiler piston valve slide crankshaft. Page 7. In 1769, a Frenchman named Nicolas Joseph Cugnot developed the first self-propelled road vehicle. This was a tractor used by the French army to carry weapons. It traveled on 3 wheels at a speed of 4 kilometers per hour. A steam engine and boiler were placed in front of the vehicle to generate power. However, the extra weight of the engine and boiler on this vehicle made it very inefficient. The tractor had to stop every 10 to 15 minutes to build up enough steam power to continue on the next stage of its journey. This illustration of Nicolas Joseph Cugnot's vehicle shows that it was very difficult to operate. Page 8. Inventors in America and the United Kingdom designed steam-powered vehicles based on Cugnot's first attempt. From 1820 to 1840, steam-powered stagecoaches, previously horse-drawn vehicles, provided transport around areas of Britain. However, as the railway system grew in popularity, support for steam-powered stagecoaches fell. Inventors then began to develop different types of engines and methods of transport. Page 9. Electric engines. In the 1830s, electric vehicles were developed. They used batteries to power a small electric motor. During this time, engineer Robert Anderson invented the first electric carriage by strapping a motor and battery onto a carriage. This method of transport was slow, heavy and expensive. It was only suitable for short journeys. Think and talk about. The electric car continued to be developed. As fuel-powered cars became popular, the development of the electric engine led to the invention of electric cars, such as this one from 1899. Page 10. Internal combustion engines. The development of the internal combustion engine in the 1860s enabled the motor vehicle industry to grow much faster. The idea of this engine was similar to that of the first steam engine, but instead of producing steam, the pressure was created by burning fuel. The explosion of the fuel moved the pistons, which turned the crankshaft attached to the vehicle's wheels. Page 11. An internal combustion engine. 1. Fuel enters the engine and is ignited by the spark plug. 2. The force of the burning fuel pushes the piston down. 3. As the piston moves up and down, the crankshaft turns the vehicle's wheels. Spark plug piston crankshaft. Page 12. Inventive engineers. Nikolaus Otto. In 1876, German engineer Nikolaus Otto built the first practical internal combustion engine, which he attached to a motorcycle. It was this engine design that was used around the world by inventors and car manufacturers as the industry quickly expanded. Nikolaus Otto. Page 13. Karl Benz. Karl Benz, a German mechanical engineer, designed and assembled the world's first car that was powered by an internal combustion engine. He was the first inventor to combine this type of engine with a specially designed frame. This 3-wheeled car was patented in 1886. A patent prevented other inventors from copying his design. Karl Benz's 3-wheeled car, 1886. Page 14. Gottlieb Daimler. In 1885, Gottlieb Daimler patented a design for the modern internal combustion petrol engine. The following year, he modified a stagecoach to carry this engine. His design is generally considered to be the world's first four-wheeled automobile. 3 years later, in 1889, Daimler and his design partner, Wilhelm Maybach, built the first complete motor car that was constructed without adapting an existing vehicle. The body of the car was designed and built to include Daimler's modern petrol engine. Gottlieb Daimler rides in the first complete motor car, 1886. Think and talk about. Many types of cars are named after the person who first manufactured them. Page 15. Mass production of motor cars. By the late 1800s, petrol cars were gaining in popularity. In fact, there was demand for these vehicles to be produced in large quantities. Peugeot and Panhard and Levasseur were the world's first car manufacturers. They built entire motor vehicles for the purpose of selling them to the public. Previous inventors had simply trialed various designs of motor vehicles to test their engines. Benz and Daimler, although beginning as inventors, went on to become large-scale manufacturers. They patented their designs and made huge amounts of money selling their engines to other companies. Page 16. Henry Ford. The mass production of motor cars moved ahead quickly with the use of assembly lines. American engineer and businessman Henry Ford installed the first conveyor belt system of mass production in his car factory in Detroit, Michigan, in 1914. This system was based on the assembly line methods used in England and other parts of America. The concept of Ford's assembly line was that workers had to perform tasks at a particular speed. They were given a specific job at a certain location in the assembly line. Workers had to remain near their job site and were not permitted to move around the production area. By performing repetitive tasks, they were more efficient and could complete more work in a set amount of time. Fewer people moving around inside the workshop also led to fewer workers being injured. Page 17. Henry Ford's assembly line. 1. The chassis is attached to the assembly line. 2. The engine and gearbox are installed on the chassis. 3. Another worker adds the steering wheel. 4. Workers then add the wheels. 5. The body of the car is attached. 6. The body of the car is painted once the car is assembled. Each worker on Ford's assembly line performed the same task multiple times a day. Page 18. Ford's method reduced the cost of producing cars because they could be assembled much faster. As a result of using this technique, the building time for each Ford car was reduced from 12.5 hours to just over 1.5 hours. This allowed 8 times more cars to be produced in the same amount of time. However, this system brought a new challenge to Henry Ford's production team, painting the newly assembled cars. Henry Ford was able to make the Model T Ford quickly and cheaply, which made it very affordable. Page 19. One of the final steps in the manufacturing process was to apply paint to the new motor cars. In the early days of Ford's manufacturing, the only paint that would dry quickly enough for the vehicles to be taken off the assembly line was called Japan Black. Because of this, Henry Ford was forced to limit the color of his cars to black. This led to Ford's famous comment that his new vehicles could be any color so long as it is black. Later, in 1926, newer fast-drying types of paint were made and a wider range of colors became available for new cars. Page 20. During the early part of the 20th century, the large number of cars sold brought about other changes to the way people lived. They no longer needed to live near railway stations. People who owned a car were more independent and could choose where they wanted to live. They could use their car to travel when and where they needed to go. At the same time, more suitable roads had to be built to provide for the increase in traffic. People were able to travel with ease as cars became more widely used. Page 21. Cars since World War II. Since World War II, cars have continued to be developed in ways that people would have originally thought impossible. Today, cars are still operated by the internal combustion engine. After more than a century, it is still the most reliable and practical system. Despite the basic design remaining the same, this type of engine has been improved over the years so it is more efficient. As technology improves, car designs change. The construction of better roads has led to higher cruising speeds for most vehicles. More advanced braking systems have been developed in modern cars. Many other features have been included to make modern cars safer and easier to drive. Heating and air conditioning have allowed people to enjoy using their cars all year round. Page 22. Today, Most new cars also have some or all of these special features: adjustable seats, airbags and other improved safety features, automatic transmission, automatic windscreen wipers, entertainment packages, cruise control, inbuilt navigation systems. Many features are controlled from a car's dashboard. Page 23. Many of these components are included in new cars, but some are options that can be chosen by each individual buyer. Because there are so many combinations of features, there are thousands of different cars available for purchase. Car yards can have hundreds of different cars for sale. Think and talk about. The price of a new car can be affected by the number of special features selected by the prospective buyer. Car yards can have hundreds of different cars for sale. Page 24. Over recent years, the use of cars has been criticized by environmentalists. The petrol or diesel burned in the internal combustion engines has caused major air pollution in many large cities around the world. The gas emissions from cars have been linked to climate change and global warming. Many governments are passing laws that limit the level of emission from cars. This has forced car manufacturers to work towards producing vehicles that use alternative power systems, such as electricity. Some companies have experimented with electric cars that can be operated without a driver. In the future, these driverless cars will become common. The Smart For2 electric drive is a battery-powered electric car. Page 25. The change from the steam engine to the modern internal combustion engine has brought about some major developments. Cars are no longer just a method of traveling from one location to another. Instead, they have become an important part of the everyday lives of people today. Owning and driving a car is pleasurable as well as convenient. For the majority of people, this individual choice represents their personal taste, priorities and standard of living. Buying a new car is an exciting experience for many people. Page 26. Driverless cars. Driverless cars are vehicles that can be used as a reliable means of transport, but are operated with little or no input from a human driver. They are also known as self-driving or robotic cars. The development of driverless cars has helped to solve some of the problems associated with heavy traffic and busy roads. These modern cars are sorted into different classes. The class they belong to depends on the degree of control the driver has as the vehicle travels along the road. Some cars may only have one or two inbuilt features, such as cruise control and automatic windscreen wipers, and rely on a driver to steer and operate the vehicle. Cars in a higher class can be self-driving or controlled by a driver. In these vehicles, the drivers sit in the regular driving position. The cars can sense if and when the drivers need to take control of the vehicles. The drivers are given adequate warning that they will be required to operate the car. Page 27. The most advanced driverless cars may operate without a driver for an entire journey. There is no need for anyone inside the car to make decisions or control the vehicle in any way. These cars are still being developed, but offer many opportunities for the future. Think and talk about. Road rules may need to be changed if driverless cars become more common in the future. Advanced driverless cars sense their surroundings using different types of technology. These systems may include cameras, radar, LiDAR, and GPS. Driverless cars use the information they receive so that steering, direction, and map reading are controlled by the vehicles, and not by a driver. The technology present in these vehicles is able to record the car's location even when the conditions change. Page 28. They are able to find their way along new streets or through new suburbs that have not previously been mapped. During the development, testing, and early use of driverless cars, their benefits have become obvious to many people. Some governments around the world are being encouraged to pass laws to make these vehicles legal to use on the roads. The technology in a driverless car enables the car to know its location, how far away other things on the road are, and the speed that other vehicles are moving. Page 29. Fewer accidents. The most convincing argument supporting the use of driverless cars is that there would be fewer traffic accidents. This means there would also be fewer injuries and deaths associated with the use of motor vehicles. Driverless cars can constantly check the traffic conditions with a 360-degree view of their surroundings. Then, if a problem arises, they can adjust to the dangerous situation faster than the average driver. Information provided by the police suggests that many traffic accidents are caused when a driver makes an error of judgment. A driver can become distracted from driving and look away from the road for just a few seconds. This can be enough time to allow the vehicle to veer into another lane or drive too close to the car ahead. A large number of traffic accidents occur when drivers are weary. Driving a car requires a considerable amount of concentration. After a long working day, many drivers are extremely tired. Page 30. The journey from work to home could be provided by a driverless car. This would mean workers could relax at the end of the day and know that they will be delivered home quickly and safely. Some motorists disregard road rules by overtaking when it is not safe or driving faster than the legal speed limits. Others become frustrated with heavy traffic conditions and behave aggressively towards other road users. All of these situations could be avoided if driverless cars were used. A driverless car can move quickly through traffic to avoid hazards such as accidents. Page 31. Reducing gas emissions. The concept of driverless cars has also become more popular in recent years as a way of reducing the quantity of fossil fuels used. Most of the development of driverless cars has centered on electric cars that have a battery that can be charged when the vehicle is parked in the garage at home or at a charging station. An electric car charges at a charging station. Page 32. Scientists have shown that the emissions from vehicles burning petrol or diesel are damaging the environment by contributing to climate change and global warming. When electric driverless cars become more commonly used, the level of emissions will decrease. The pace of global warming would slow as a result of this decrease. Think and talk about limited supplies of coal and oil will have a strong impact on the design of cars in the future. Vehicle emissions are a major contributor to air pollution in Beijing, China. Page 33. Fewer car parks currently. Large areas of valuable land are allocated to car parks. Inner city high-rise buildings and shopping centers in the suburbs need to provide adequate parking facilities for the people who work or shop there. Many people who work in the cities know that it is often difficult to find suitable parking spaces during a normal working day. If driverless cars were introduced alongside car-sharing services, vehicles could deliver passengers to one destination, then drive to other locations to collect more passengers. These vehicles could move around the city all day, only stopping to set down or pick up passengers, in a similar way that a taxi service operates. There would be no need for multi-story car parks for cars that remain parked for long periods of time. At the end of each working day, people would be collected by a driverless car and returned safely to their homes. Page 34. This system of transport would significantly reduce the total number of vehicles using the roads, because one vehicle would be shared by many people throughout the day. Driverless car sharing possibilities. A driverless car delivers a passenger to one location. The same car drives to a different location. The next passenger uses the driverless car. Page 35. Improved traffic flow. Another important argument in support of driverless cars is that the flow of traffic can be better managed with the use of these vehicles. Cars that are controlled by technology can actually travel faster and closer together. For driverless cars, the recommended safety gap between vehicles could be reduced without having a negative impact on traffic flow or safety. These driverless cars will be able to send instant electronic information to the other cars, which means that their movements will be well coordinated, even though there are many cars on the road. A driverless car parks without the driver's control. Page 36. Driverless cars receive up-to-date information about road conditions, speed limits and directions through their control systems. This means that the cars can anticipate any hazards and work to avoid them. As a result of these systems, traffic will flow smoothly. A driverless car moves safely through traffic on a test drive in California, USA. Page 37. Personal benefits. Many people would benefit from having access to a driverless car. In a driverless car, parents would be able to spend more time talking to their children on the way to school, sport or social events. At the end of the school day, or the conclusion of the event, families would return home in a driverless car. Families would therefore be able to spend more quality time together without having to worry about concentrating on the road. Families could spend quality time together while in driverless cars. Page 38. Driverless cars could also benefit people who are not able to drive themselves, such as disabled or elderly people. Other people who do not want to drive or do not like driving would also be able to travel easily in driverless cars. This would improve the lives of many people. Think and talk about. With driverless cars, people would no longer be required to obtain a driver's license. Driverless cars are being tested by people who would benefit from them in the future. Page 39. The future of driverless cars. There are many arguments for the development of driverless cars. The most significant argument is the reduction in injuries and deaths caused by motor vehicle accidents. However, slowing the rate of global warming, maximizing the use of land in our cities, and improving the lifestyle of busy families and people who cannot drive themselves are all added benefits. In light of these arguments, It is clear that in the near future, car manufacturers will pursue their goal to produce driverless cars that will suit the needs of the average motorist. Driverless cars will become a part of everyday life in the future.